we are going to start now with an electrochemical cell, right? So first of all, you should know what is an electrochemical cell and what is the principle behind the electrochemical cell, right? So the first we'll be doing that what is the electrochemical cell, right? It is actually a cell which convert chemical energy into electrical energy. That means in it the chemical reactions will occur, and that chemical reaction will lead to the production of electric energy, right? So that means these are the cells which what they do in them the certain chemical reaction take place. That means the chemical energy just get converted into the electric energy, right? This is the electrochemical cell. Now the question must be rising in your mind, or we should be curious to know that what is the principle behind the electrochemical cell, right? The principle is that in it indirect redox reaction take place, right? In it indirect redox reaction takes place. As you all are familiar with the redox reaction, you know that redox reaction is a reaction in which oxidation and reduction both occur simultaneously, right? You know that what is oxidation and reduction, right? But what happens, like earlier what we were doing the redox reaction in a direct manner. That means we were taking a beaker, and in the same beaker some atom was losing an electron and some atom was gaining an electron. That means oxidation and reduction was taking place in a, you can say, in a same beaker, right? And the electrons given by the one atom and the same electron remain in the same, you can say, the beaker, and they are taken up by some other atom. So that means electron was not allowed to travel a long distance, right? So in that case it is called as direct redox reaction. So again I am repeating, direct redox reaction is something like that in which the electrons are not allowed to move through a certain large distance, right? That means oxidation and reduction occur in a same beaker, or you can say the atoms which undergo oxidation or reduction, they are present in a same beaker. They are not present far from each other, they are present in a close contact. So what happens whenever the direct redox reaction take place, we do not get you can say the electric energy. That means electric energy is not produced. But when we allow that electrons to travel a certain distance, and you can say, like, if there is some atom which is losing an electron and these electrons are just made to move through a certain distance, then they constitute a current. That means the chemical energy is converted into the electric energy, and that type of redox reaction is called as indirect redox reaction, right? So in the principle for this electrochemical cell is that the indirect redox reaction, that means the atom which will undergo the oxidation and the atom which will undergo the reduction, they are not present in a close contact, they are present far away. So the electrons need to travel a certain distance to reach to an atom which needs an electron, and there is a gap between them, right? So and this movement of electron just constitute the electric current, right? So I think it is clear that what is electrochemical cell. You're right, electrochemical cell is a device which convert chemical energy into electric energy, or you can say that in it chemical reactions take place which lead to the production of the electric current, right? One and the same thing. And the principle on which it is based is that in it the indirect redox reaction occur. That means the electrons are made to flow through a certain distance. So that means oxidation and reduction are not occurring in the same beaker, right? So this is the electrochemical cell. Now let us see how it works. What is its apparatus? What is the setup actually, right? So just look at the board and just draw the figure. First understand and then draw it in your copies as well, because whenever you will be answering this question you need to draw the figure, right? It is very important. So what is it? Just look at the board. It consists of two beakers. One beaker. So I am writing beaker 1, right? The other beaker 2. Right, is it okay? Then what we are having in this beaker, we have in beaker 1 zinc rod dipped in 1 molar ZnSO4 solution, right? And what we have in beaker 2, we have copper rod dipped in 1 molar copper sulfate solution. Right, is it okay? See, the beaker 1 containing the zinc rod and ZnSO4 solution. This is the copper rod dipped in copper sulfate solutions, right? Now we need to connect these two beakers because the oxidation and reduction will take place in them, and we need to have a certain contact between them through which the electrons can flow. So how they are connected? These electrodes are connected by means of wire, right? And in the mid of wire there is a device which can just indicate the current. It can be an ammeter or a galvanometer, right? We have an instrument, one is galvanometer, one is an ammeter. Ammeter is a device which has very low resistance, right? And you can say it is also used to measure the current, and galvanometer is also an instrument which measures the current, but galvanometer is so sensitive that it can measure even the small amount of current, right? So what we are taking here, commonly what we use ammeter. So what I have taken here, it is an ammeter which has a needle which shows the deflection whenever the current is produced, right? We have the wire, we have the switch, right? Or you can say we have the key. This is ammeter, we have the key, and by means of this these electrodes are connected to each other, right? So this is how these two beakers are connected to each other, right? Now what we get to see, I think it's clear, it is just wires. I'll just draw it properly, right? Is it okay? Now what is there? These we have this beakers connected in this way, and we also have the solutions connected with each other, and the connection between the solution is by the salt bridge. Now what is it, right? Salt bridge is actually formed of the inert electrolyte in agar-agar solution. Right, these are how we form the salt bridge. What we do, we just take inert electrolyte and the agar-agar solution, we just heat them, and when they mix thoroughly, we just you can say we just cool it, and we just draw into a tube-like structure, a U-shaped structure, right? And this U-type structure is just used here to connect the solutions, as I'm showing here. So this is a salt bridge, U-shaped, right? And these openings are just plugged with the cotton plugs. Right, so this is a salt bridge. It actually plays a very important function, this salt bridge. We'll be discussing later. So I think this figure is clear to you, and you are familiar with it, that how the salt bridge is formed, right? You need to know that it contains an inert electrolyte. Suppose I take an example, KCl. You can take K2SO4, any like the inert electrolyte. So what I'm taking is KCl in agar-agar solution. So this is an electrochemical cell. That means it is the setup for the electrochemical cell, right? So you need to know this figure. You should be well versed with the figure, because whenever you will get a question, you need to draw the figure first, because you should be familiar with the apparatus which is actually used, and what kind of, then we'll be looking for the working, right? Now just we'll start with the working now, that how it is working, how the oxidation is occurring, and how these two beakers are there, and what kind of changes we observe in these beakers. So what happens, we are just doing its working now. So initially what happens, when the switch, or you can say key, is off means like this, there is no connection between the wires, then what we get to see, nothing. There is no deflection produced in an ammeter. There is no deflection produced in an ammeter. That means nothing happened, right? So that means when this key is opened, we get to see no deflection in the ammeter, indicating that there is no production of electric energy, no conversion of chemical energy into the electric energy, right? Then what we do, we just on this switch now. Look, I've just on this switch, on this key, you can use the word, you can use key or you can use the switch. So what happened, we just on the switch, then we go, what we get to see in that, we get to see that this zinc rod starts losing weight. Why it is losing weight now? Because it is undergoing oxidation. These zinc ions are, zinc atom is losing its 2 electrons and forming this zinc ions, Zn2 positive, right? So that means zinc rod is now started losing its weight because it gets converted into the iron, and along with that what it is producing electrons. Now what is the fate of these zinc ions and what is the fate of these electrons? I mean, where they will go now? Then what happens? See, I'll write here also in the figure because it will be more clear to you. See, the zinc rod, what is happening? This zinc is losing 2 electrons and forming Zn2 positive, right? These Zn2 positive are going into the solution. Again, I am writing here. These zinc ions are going into the solution, that means in the ZnSO4 solution which is present in a beaker, right? And now what is the fate of these electrons which it is losing? These electrons are made to move through this wire, and in doing so they just show the ammeter just show the deflection as well. That means we know that the electron just lose weight, the electrons when move they constitute electric current, right? So when they move they just they indicate that there is a flow of electron, that means there is production of electric current. So that means ammeter shows the deflection and these electrons just reaches the copper rod. So what is the fate of these electrons? They will move towards copper rod by means of wire, and what we get to see, we'll get to see the ammeter showing the deflection. That means it indicates that there is a production of current. So ammeter is showing the deflection in this case. Right, again we'll be repeating. Then what I have told you till now, see, when the key is off we get to see no deflection because nothing happened, no chemical reaction take place, or you can say nothing happened in that case. And if in case the reaction is still taking place but we don't get to see any electrons moving, right, because we need to have a connection between the wire if we need to have electric current in the circuit. So that means when the switch is off, though the chemical reaction is taking place but there is no production of electric current, that means there is no deflection in the ammeter C. But when we on the switch, we just make the connections, complete connections, what we get to see that in this beaker, in beaker 1, I'll write here, in beaker 1, zinc rod starts losing weight. Why it is losing weight? Because zinc has a tendency to lose electron. So that means it is undergoing oxidation and it is losing electrons. You can see it is losing 2 electrons and forming zinc ions. Now the question is that what is the fate of these zinc ions and these 2 electrons? So these zinc ions will now go to they will just move to the solution because the solution contains the ZnSO4, that means zinc positive, zinc 2 positive and sulfate ions. So obviously the zinc rod is losing weight, but the concentration of you can say what we get to see, we see that zinc rod is losing weight but the concentration of ZnSO4 solution is increasing. Why it is increasing? Because these zinc 2 ions are just going into the solution. So that means we get to see that the rod is losing weight because it is losing 2 electrons and the atom is getting converted into iron as it is showing oxidation. But these ions, zinc ions, are moving into the solution. That means though the zinc rod is losing weight, but the concentration of ZnSO4 is increasing with time. So this we get to see in this. And what is the fate of these electrons? These electrons are they move by means of this wire, and when they move they just show the deflection in the ammeter, and what they are doing, they are just moving and they are just reaching the copper rod. Now what happens when they reach the copper rod? What we get to see, when they reach copper rod, or you can say when they reach beaker 2, these electrons are picked up by the copper ions. Right, as we know it is a solution, so obviously there are present copper ion and sulfate ions. So that means these electrons are just picked up by the copper, and these copper ions gets converted into the copper atom, and this kind of deposition starts, this copper start depositing on this copper rod. So that means what we get to see in this beaker 2, we get to see that the copper electrode is gaining weight due to, why it is gaining weight? You know that due to deposition of the pure copper on it as a result of reduction, right? So it is just gaining weight, and the concentration of CuSO4 solution is just decreasing with time. So this we get to see in beaker 2. So that means, and what is this process called? The gain of reaction, the electrons is reduction. So this is what is happening in the electrochemical cell. So what can be the overall reaction? What overall reaction we can write? We can write that earlier it was zinc atom and it was copper ion. What they did, zinc lose electron and converted into the ion form, and copper was reduced. So this is actually the overall redox reaction which is taking place in this electrochemical cell. Again, I'll be repeating for you for your convenience. When the switch is off, there we get to see nothing, right? But when the switch is on, what happens? Zinc rods starting losing weight. These are losing weight and they are forming zinc 2 positive ions. These 2 positive ions are going into the solution, and these electrons are just moving by through this wire, and when they are moving, they are just showing the deflection in the ammeter, indicating the production of electric current. And what happens when these electron reaches the copper rod? They just make the copper ions reduce. That means, as you can see here, the copper ions are gaining 2 electrons and then converted into the copper atom. And what is the fate of this copper atom? The coating start getting deposited on this copper rod, right? So what we get to see with time, we get to see that this rod is somehow losing weight, but the concentration of ZnSO4 is increasing, right? And in a beaker 2, copper rod is gaining weight, but the concentration of CuSO4 is falling with time. And so that means, what is the overall reaction? So overall reaction is this, that is Zn plus Cu2 positive forming Zn2 positive plus Cu. I'll write we'll just indicate the oxidation reduction in them. As you can see, zinc is losing 2 electrons, so that means it is an oxidation. This copper ion is gaining electrons, so it is reduction. It acts as reducing agent, it acts as oxidizing agent. You know that how we indicate oxidation and reduction, and what are the oxidizing agents and the reducing agents, right? So this is the electrochemical cell. And you are familiar with the working as well now. But the one question is still unanswered. So you must be curious to know that question. It is that, what is the function of this bridge? Because as I told you the whole working, but I haven't told you the working of salt bridge, or what kind of function the salt bridge is performing in the functioning of the electrochemical cell. As I told you that salt bridge plays an important role, it is actually playing an important function. So just look at the board that what actual important function the salt bridge is playing, right? So this function of salt bridge is that, as you can see, that it is just completing the circuit. The first use is that it is just completing the circuit. How it is completing the circuit? As you can see, it is connected, see, the rod and rod, or you can say the electrodes are connected by means of wire, right? So that means it is completing the external circuit. But what the salt bridge is doing, it is also connecting the one solution and the 2 solutions. So that means it is just making a better contact, or you can say it is just completing the circuit. So first use is that it is just completing the circuit. Now, second use is a very important use. What we get to see with time, like as you know that the zinc rod is losing electrons and the copper ions are just gaining electron and turning into the copper atom. So what we get to see with time? We get to see that when this, with passage of time, when more and more zinc atoms are losing electron, they are forming Zn2 positive. So that means this rod gets surrounded by many Zn2 positive ions. So as you know, there is always an equilibrium. See, I'll write here. As we know, so that means with passage of time, more and more zinc atoms are just losing electrons, right? So that means there exists an equilibrium. That means the rate at which they are losing an electron, or you can say the rate at which the zinc atom is forming the ion, is equal to the rate at which the zinc ions are getting again reduced to the zinc atom. So what happens? When with passage of time these electrodes get surrounded by many zinc ions, they will just you can say disturbs this equilibrium, and it will further prevent the oxidation to occur, right? So that means it will, as you know that there are so much positive charge, so they will not allow more positive charge to be formed. So that means they will just prevent the oxidation, right? So and if the oxidation will be prevented, so that means there will be no electrons formed, and if there will be no electrons formed, so that means the the production of current will stop. But we don't need to stop our cell from working. So what happens, so just look at the board, how the salt bridge just help the cell, the electrochemical cell to keep on working. So this is the problem what we face in beaker 1, right? But there is a problem still which is existing in the beaker 2. So just look at it, what is the problem in the beaker 2? As you can see in the beaker 1, the rod is just surrounded by the positive ions. What we get to see in the beaker 2, we see that as we know, the copper ions are just gaining electrons and turning into the copper atoms, and they are just coated on this, right? So we get to see there are many sulfate ions which just surround this, that means the copper rod. So they will, so see, as you can see, the sulfate ions are the negatively charged ions. So that means they will just prevent, or you can say they will just repel the negative charge from coming. So if there will be less negative charge coming, so that means how the copper will get reduced, right? So at that moment, the salt bridge plays an important function.